In this video, I would like to talk about the palindrome problem, which is a quite common problem which deals with writes a function that takes a string and returns true if it is a palindrome and false otherwise. And if we look into the definition of a palindrome, it's a word, phrase, or sequence that reads the same backwards as forwards. Example, madame or nurses run. So let's take these two examples. So I'll say madame, and I'll say nurses run. And I'll say something else as well. So palindrome, the word palindrome is obviously not a palindrome, right? So let's try these test cases. But so one simple solution is to basically create another string which is the reversed string of this, and then compare them as a basic string comparison. So it's kind of just to check if word.reverse. I guess that this is a dot. I don't know how you would do the reverse here. I guess there was a. Of course, there's no reverse string on reverse method on the string, so we need to split this to an array, and then we reverse it, and then we join. Right, and if this is the same as the word itself, then it's a palindrome, I guess. So if I run this, and maybe I should console log these out. Then I hope we would get. Of course, I need to do something more. That's not sufficient. We need to take of course, this is not correct because it's not madame with an E. So right, so I'll remove that, and then the first test case hopefully will run. So true, that's correct. This is still false because we don't check the empty spaces, right? So we need to kind of remove that as well. So I'll say replace. It's just a really silly solution right now, and hopefully I need to do this when it's still a string, and hopefully both will be true. Still not. Of course, I need to do this in both places. This is starting to get really ugly, but yeah, let's try it. And now we get true, true, false, right? Which is the expected test case. So this is running correctly, but it's not a really good solution from the point that you need to replace things, you need to split things, you need to reverse them, you need to join them, and then replace again. So you're doing quite a lot of things to make this work, right? So you need to kind of check things, and we're still not checking if it's uppercase or lowercase. So then I need to like use lowercase as well, so that if I say madame with a big M, and nurses run and palindrome, then it should still work. So let's see, to lowercase. I hope that this will work. Yeah, and it still works. But it's not a good solution according to me, and there are better solutions. We can do this. And what I want to show here is that we should maybe take a step away from the code and instead look at the problem from a logical perspective without involving code. So for this, I would like to look at just drawing some things. Okay, so right now I've typed Bob. Maybe I should remove this, and I'll say madame instead, since that's the word that we're having right now. So a really good solution to this problem, which is also a more optimal solution from the point of time complexity. Usually when we talk about algorithms, we talk about what is called time complexity, or how fast does it run, how fast does this function run or this code run. And we would ideally not want to do operations like reversing strings and doing all these types of comparisons and running like looping through an entire string, kind of creating new variants of strings. We don't want to do that. We don't need this, to be honest. So a simpler solution would be to actually look at it from a more logical perspective. So how would you determine a palindrome as a human being? You know, many times when we deal with a problem, it's nice to kind of look at it from a more logical perspective without even looking at code. So I would say that from a logical perspective, it makes sense to look at the first letter and the last letter, right? So if these two are the same, then we can say that, yeah, it could be, there's a big possibility that this is actually a palindrome, right? And then we can kind of look into the two other letters that are, yeah, more to the middle. So for this, we can remove these pointers, and now we can try to maybe look at these two instead, right? The A and this one, which is still the same, right? A. And then we only have one letter left. So we will look at this one, which is, yeah, which is this letter, and yeah. So we would say that this is now a palindrome. We would make this conclusion. So without actually having to create strings or do things like trying to like write this in a reversed order and check it. We don't have to do those things. You only have to look at the beginning and the end of the string. So this to write this in code, or to solve this in code, we would need two counters, right? So first, I would say beginning would be and when I say counter, I mean it should be an integer, right? So I'll say 0, and the end would be the last index of the string, right? So word.length -1. That's the end of the string. And what you might do in the beginning is that if the word is like an empty string, so if it's empty, then we return. Otherwise, we do these things. So let's just look at it now. So what I would do is I would get the first letter and the last. So I'll say first. This is now word beginning, and the last is the word end, right? And then I check while first. Maybe I could do it like this as well, right? I don't need to save them as variables. I can just say while the first letter is if it's not the same as the last one, then we return false, right? Or actually, I would say if they are the same. So basically, what I said when I typed it out. So if they are the same, then we want to kind of increment the beginning and decrement the end. So we'll say beginning should be incremented and the end should be decremented. Or actually what I would do is I would change this condition to be while beginning is less than end, right? Because that needs to be the condition. And if I have this, actually I don't think I need this if statement either. So I'll say while beginning is less than end, we increment the beginning and we decrement the end, but we also need to check if the beginning is not the same, or the first character is not the same as the last one, then we return false, right? Otherwise, we just increment and decrement. And at some point, this will evaluate to false, right? And if we have exhausted the whole string, then return true at the end, because we say that yes, we exhausted the whole string, and it's actually a palindrome. I want to check the empty string case. So I'll say, what happens if it's an empty string? I think that maybe we need the if statement I added before, but let's try this out. Let's see. So now we have 4 test cases. Maybe I should clear the console and run this again. Yeah, so apparently this is not working at the moment. This is true, which is shouldn't. So then I think I will add the if statement at the beginning. So if the length of the word is 0, if it's an empty string, return false. Right, so this should now return false for the first case, which is nice. And then of course here it will all be false because we have uppercase letters, right? So I need to kind of normalize it. So I'll say 2 lowercase, and the same here for the second character, 2 lowercase. So let's see. Now this is true. This is still false though, which is interesting. And I guess that the reason is that we have these white spaces, right? So we need to kind of maybe use a trimmed word, or like the string should not be the same that we have, but we should kind of normalize it. So I'll say normalized word should be to lowercase, and it should be trimmed, and we should also replace I think it's like this, I'm not sure, and then we use the normalized word. We don't use we don't need to check this again, right? Hope this makes sense. So we need to kind of yeah, I can just say normalized. Yeah, normalized word works fine, I guess. So let me run this again. Let's see what happens. Of course it fails, which is interesting. So I think I'm missing out something here. I think I need to actually, I'll just say if it's a space, then we want to replace it with an empty string, right? So we're just removing all the empty spaces in the string. This should work. Let's see. Yes, and this returns a correct the correct outputs, right? So the first one should be false because it's not a palindrome if it's an empty string. Madame is correct because it is a palindrome. Nurses 1 is also correct, even though we don't care about the empty spaces and we don't care about the uppercases. And the last one is of course false because it's not a palindrome. It's not a palindrome, right? The word palindrome is not a palindrome. So I hope this code makes sense to you. So let's just walk through this code to kind of make sense of it. I think I will minimize this a bit so we see the whole function. So the first case is that if it's 0, and maybe what we should do is that we should also kind of run this to cover this case, right? So let's say if I say is palindrome with an empty space, right? I guess this will return true. Let's see if it does. Yes, it returns true, and it should not return true. So we should check not just this, but we should actually check this whole thing, right? So if it's lowercase and we don't have spaces, and this is still 0, then we return false. So let's see if this works. Yes. So this is false. This is false. This is true, true, and false. And maybe to make this clearer, maybe we should print the argument before we actually. Yeah, maybe that's not necessary, but I hope this makes sense to you. I hope you understand that these two should be false, these two cases, and these two cases are true, and this last one is also false. So this code it's more code than the previous solution. The previous solution was just one-liner, you would say, but this code is much more, I would say, much more efficient due to the fact that we're making use of two pointers, so the beginning pointer and the end pointer, and we're checking as long as beginning is less than end. Then we want to check that if they're not the same, then we exit out of the function. And this also means that, for example, when it checks this what makes this so efficient is that it first checks the first letter and the last one, right? And if it immediately identifies that these are not the same, then it will exit out of the function immediately. So it won't even exhaust the whole string. It won't search anymore because it already knows that it's false, right? So it doesn't have to continue. So that's why it breaks out of the function immediately and returns false. So this is one of the things that makes this so efficient. So for many of the use cases or the test cases, if you have like a really strong, really long string, then as long as it finds that something is not correct, then it will not even bother running through all these characters. So this is what makes the algorithm so efficient. And yeah, so this was kind of what I wanted to show you in this video, and thanks for watching.